Hello there. I don't have anything snarky to say today, so let's get on with it. Just to be clear, this is how I draw a zero. You can thank oxygen for that little fact. So as it was suggested, I'm going to start with U substitution. So U is going to be this expression right here, once I find the color, and I'm going to write down the derivative of U in terms of R. So derivative of 1 is just 0, e to a power is just the same expression times the derivative of the exponent, which we can see is just 1 over a. So just rearranging this, adding plus 1 minus 1, these will cancel, but this term is conveniently u. So finally rewriting it one more time. So now I'm going to rewrite the original integral in terms of u. However, I'm going to keep the bounds in terms of r, just because 0 is a nice number. So the denominator here is just u, so we rewrite it as 1 over u, and then we can see from du over dr that changing the variable of integration, we just take the inverse of this, or the reciprocal. And because a is constant in terms of u, we move it outside of the integral and just rewrite it one more time. In order to be more user-friendly and take advantage of a integral identity, I'm going to rewrite this using completing the square. It's just writing it in this format. In order to get minus 1 as a coefficient, I have to use minus 1/2, and then to cancel out the positive 1/4, just subtract 1/4 off the end. So rewriting this one final time. And I have a habit of drawing tinier and tinier and tinier until I'm at the very smallest pencil size. I'm sorry. No, I'm not. I'm also going to write 1/4 as 1/2 squared, and you'll see why in just a bit. So here is a proof for that integral identity I just mentioned. If you want to go through it on your own time, go ahead. However, I'm just going to copy this and use it. So using the variables that I've written down in this identity, we set y equal to u minus 1/2 and b equal to 1/2. So rewriting the problem using this identity, a, and then we have 1 over 2b, b is 1/2. We have to rewrite this entire section to be evaluated as a definite integral rather than an indefinite integral. And these actually aren't squared. And I'm going to rewrite this again, just a little bit cleaner. Now to actually evaluate over the bounds of the integral. I'm going to solve u in terms of r for each of the two. So taking the definition, so as little r approaches infinity, the exponent blows up, and u approaches infinity as well. But if little r is 0, then, well, I'm just going to steal this. By rewriting u to the negative first power as 1 over u, it becomes fairly obvious that this half of this expression approaches ln of 1, otherwise known as 0. The other half, I'm going to rewrite. And with that bit of algebra, I, I, I don't even know what it is anymore. I would not call it wizardry. It is an abomination. But we're moving on. Rewriting it again, just a nice clean format. And I can't simplify it any further, at least not reasonably, that I can think of. So we're going to toss it in Desmos and see how it holds up. So along the bottom, you can see the same expression. And we also have the function up at the very top and a converging integral that gives the same value that I decided to poke around with because I don't know. Have fun. Have fun with past me poking around. I'm leaving.